There I am. I'm back in my classroom. This is weird. This is just flat out weird. I'm not sure I like it. Well, here we are. Here we are nonetheless. Now, I haven't been back in my classroom. I actually haven't been to my classroom since November 19th. So I haven't been here in like 11 days. So this is very weird. I don't know. Just to make sure you guys can, I can see the little microphone thingy at the bottom, but I'm pretty sure you guys can hear me, right? I just want to make sure as I kind of get ready for what I want to plan today, or what I'm planning to do today. Something along those lines. I don't know. As you tell, I'm probably a little tired, probably a little down today, simply because there's no people here, and I much prefer teaching in front of people. I don't know. But that's me. That's me. Anyway, here's what my plan is, so to speak. Now, obviously, this week I have you Monday, Wednesday, Friday. I am going to be beginning the introduction to a new unit that we're going to be covering. We're stepping away from the realm of statistical analysis, which we finished up with the normal distribution, and we're going to be getting into more of the probability half of this particular class, so to speak. Now, it seemingly is I only got 4 people in the chat right now, which makes me sad because there's like 10 or 11 people in the class. Hopefully they'll come back and watch a little bit later. But what I want to do first, I want to take an inventory as to what you already know about probability. I want to take an inventory about what you already know about probability. I do have a brief quizzes lined up for that. Now, I altered this quizzes so that, because I keep forgetting to do this for the practice ones, that I really want to do. But I altered this one so that you could actually see what you got right and what you got wrong as you're moving throughout the quizzes. Again, this is a practice one. This is more of an inventory as to what do you know about probability. Obviously, probability is one of those basic concepts that a lot of people are like, I generally have an idea as to what to do with probability, and good for you. High fives at a distance. But there's a lot of things that people misunderstand along the way. So in a moment, I am going to put the code for said quizzes up on the board. It's going to be very, well, it's not brief in terms of number of questions, but it's going to be brief in terms of the amount of time that I give for it, because a lot of these questions are mainly like, you think about it for like 10 seconds and then you choose, or you have a brief calculation and then you choose, or something along those lines. Nothing out of the ordinary. Now, as a reminder for those that are here, you do have an assessment due for me today at 2:00. Obviously, the school day only goes till 11:40. So with whatever time you have today, if you haven't already done so, I'm going to need that assessment submitted. I already have one submitted already that I'm going to hopefully take a look at later today at some point. But I'm probably not going to get to grade them for like a day or two, or something along those lines. But that will be the wrap up to the normal distribution unit that we were covering. Yeah. Anywho, I read a news article, really interesting. I don't know if you guys saw it. Governor Murphy had said that a total shutdown, or a New Jersey state shutdown, was not off the table, but he was going to use it as like a last resort or something like that. I'm just tired of like the back and forth and back and forth. That's what I'm really tired of. But say la vie. I don't know. Anyway, I'm going to bring up that code so you guys can get logged on as quickly as possible. And then after, I would just like, I'm going to have those results for myself, because I want to see what you were capable of doing on your own without any help from me whatsoever. Now, obviously, I bring the code up here, but you can't see said code. You can't see it because there's a giant glare in the way. Oh, no. I know, I'm tired. I know. It's just one giant thing of life. Anyway, here's the code for you guys. It is 658.078. And I have no idea whether or not you can even see that. Probably not. So I'm going to type it into the chat. 658.078. Boom. Here we go. Sorry, I just saw your comment. But yeah, 658.078. I do apologize because this marker apparently doesn't want to show up too great for me. I'm going to try and write it again. This orange might be a little bit better, so we'll see how it goes. 658.078. You can see I can see that a little bit better, but at least I put it into the chat. So if you can't see that code, and I really should find a better marker, I'm going to throw this one out. Go away, marker. I totally made that, by the way, just so you know. But anyway, hold on. There's an announcement.
Frankfurt Tech, please come to the main office.
Yes. We need those tech guys working on stuff because you got teachers who are trying to get things done in class. But anyway, let me try to write that one more time with a different marker. Yeah, sick. Yeah, like that works any better. Can you even see that? Well, you can see that a little bit better. 658.078. Good. Now, yeah, a little bit better. Now, if you haven't checked in yet, because I only see 3 people who have checked in. Some people ask me, like, do I click the start thing? And like, yeah, click whatever you do, because you can get to a point where you can change your theme, and then the game won't actually start until I click it. So please make sure you're jumping on that and getting signed in here, because again, I need to have an inventory of like, this is what we know, this is what we don't know, and it'd be very helpful. What is the requested format? I don't understand. What do you mean the requested format? Odd. I don't know. MLA? American something? I don't know. But yeah, I want to see more people signed into that. I'm going to start the game probably in the next 30 seconds. So if you have not signed in, please make sure that you are signing in, and then I will get that thing done. And we'll get moving with it. Oh, happy day. Make sure you have that calculator open on the Chromebook as well. That calculator can be helpful for some basic calculations that we have going on here. And then we'll get this thing going. Oh, here come more people popping in. There we go. All right. I heard the pop on the thing, so it was great. Anyway, I'm going to go click that start button. Again, if you haven't signed in, that code will remain there, but I believe when I click start, the code will show up a bit more prominently across the top of the screen. So let me get that thing moving. Here we go. I'm going to start it. Click. I'm going to lower my volume. And I'm going to try not to disturb you. as we're coming up to the end of this, I'm going to give you guys an additional 2 or 3 minutes. 2 or 3 minutes to wrap up these questions. Sorry, Sky, I just saw your comment, so that's funny. Here. Put that over here. Okay. I'm going to click to end this thing in the next moment or so. I do apologize for those that are still knocking this thing out, but I would like to move ahead with the notes that I had planned because I reached the time of 7:50, which is the time that I would like to kind of jump ahead with this. So, what do we got here? Click, click. There we go. Boom, 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 boom. There we go. I mean, honestly, we did pretty well with this one. I mean, like as a class, we averaged over 70%, which is pretty solid. Let me take a look at some of these questions here. There was only one question in the red. This question right here, which at one point or another we will talk about why that is what it is. Plays an instrument or a sport. Nice. So I can see a lot of you picked 11 out of 20. Nice. Okay, yeah. Again, we're going to talk about why that is, but I'm not going to give that away just yet. So what I'm going to ask of you, if you do not already have them out, I'm going to need those notebooks out and open. Here we go. I gotcha. Yeah, like I said, this quizzes was mainly an inventory of, okay, what do we know? What do we not know? What do we need to work on? What do we need to focus on or pay attention to? Things of that nature. The whole purpose of today's lesson is meant as an introduction to the concepts of probability in this course. Now, we're going to deep dive a lot of stuff. Eventually, we're going to deep dive a lot of stuff. But we'll get to that. So, Today is November 30th. We'll call this Intro to Probability. Excellent. Now, just so you know a little bit of my background. Also, again, I do apologize for the glare. I requested it. I put in the request of like, hey, I teach better from home because I have the better setup. And then they're like, well, what do you need in order to teach better? We're like, well, I need OBS Studio. If I had OBS Studio I could do it very easily. I'm still waiting on that. So hopefully this week I'll be able to get in contact with someone from IT and you'll have a better visual on the computer than you do here. It's just, come on, seriously, with this glare, I'll try to work around that as best I can. Anyway, a little bit of background on me. Some of you may or may not know this about me, but I have a dad who is very much, in the past, addicted to gambling, very much addicted to gambling. My dad, when he would, take me out to special trips or whatever, of course, we'd go to baseball games and, we would go to the park and stuff like that. But then, we'd go to the racetrack, and this is completely legitimate. My dad would take me to the racetrack and bet on horses. And to this day, whenever I get a whiff or a waft of cigar smoke, it takes me back immediately to those times that I went with my dad to the racetrack. There was one time in particular where we went down to the Atlantic City racetrack, and my dad had a certain amount of money set aside to bet on horses. He knew that he was going to bet on this many races and this much money per race. And he had enough money to pay for him to get in. So he didn't have enough money for me. And I was like 8 years old. And I'm like, well, what do I do? And he's just like, you're going to have to jump this fence. So as an 8-year-old, I had to jump a chain link fence and wait for my dad on the other side so that he didn't have to pay for me to get into the racetrack. So he had enough money to bet on the horses. So, it's just one of those things. No, but I was the only 8-year-old who understood all of this stuff about betting and probability and things of that nature. It was really interesting, understanding odds and that was the beginning of my training that my dad had me kind of going through, incidentally, training for statistics and probability. And here we are. So, a couple of pieces of background information. Sorry, I'm still looking at the chat. I have the chat open right here where I'm sitting, just so you guys know. I'll be able to see what you guys are commenting if you have any questions as we're moving forward. So first of all, probability can be measured between 0 and 1. Something very specific that I want to get into. If you're dealing with decimals. If you're dealing with decimals, then probability can be measured between 0 and 1. As a statistician, it is important to be able to recognize that fact. So if you have something that's 0.75, you could immediately recognize it as 75%. If you have something as 0.01, you can immediately recognize it as 1%. But keep in mind that probability is typically measured between 0 and 1. And the answers that you will typically see in these problems will typically be measured as these decimals. It can also be between 0 and 100 if you're dealing with percentages. So different kind of scale. I just want you to be aware of that fact. The fact that probability, depending on what you are measuring it in, could be between 0 and 1 for decimals or 0 and 100 for percentages. So if there's a probability of 1 for a certain event happening, I want you to be able to interpret that as, 1 is the same as 100%. If it ends up being a percentage, they will most likely use the symbol for percentages. Keep in mind, we can also measure it as a fraction, but fractions are nothing more than decimals. So you may end up seeing it as a fraction. But again, If probability is to be measured as a fraction, it will still also be between 0 and 1. Let's talk about notation. You might see a probability question being written like this. Let me zoom in a little bit, make that a little bit more. There we go. P parentheses event. This is the probability of a certain event occurring. And they may ask you that question in that kind of form. And this would just be probability of an event. And I'll give you a few examples of that in a moment. It's function notation. That's really what it is. It's f of x, but it's p of event. That's all that it really is. The input is the event that is occurring, and the output is the probability of that event occurring. So I could say something like the probability of rolling a die. The probability of rolling a die and getting a 3. The probability of rolling a die and getting a 3. And that's something that people are very familiar with just because they use dice in various games and whatnot. So I can just take like a random die. I think I don't have a regular die. Why do I not have a regular die? I have like all these like weird colored dice. I thought I had regular dice somewhere. Hey, my marbles. Guess what, guys? I found them. Anyway, so here's a not regular die. That's not a regular die, simply because it doesn't go 1 to 6. It actually goes 0 to 5 for some reason. I'm not sure why. But clearly, if you were to study a die, you would say like, oh, it has 6 possibilities. Cool. 6 possibilities on this die, and only one of them happened to be a 3. So that would just be 1 out of 6. And you'd be like, yay, I did it. 1 out of 6. Yeah, of course. Sorry. I keep reading the chat and it makes me laugh. But rolling a die and getting a 3, 1 out of 6. There's one chance of that event happening out of 6 possibilities. Of course, typically writing a probability as a decimal is a much, much, much better practice. And in this case, it'd be approximately 0.1. I'll go 167 just for the sake of argument. You could also go 0.17 if you wanted to. But typically, again, we want to write them as decimals simply because it makes sense. Because if you had 2 random fractions, like, 14 out of 17 versus 15 out of 18, could you immediately tell which one is bigger? I'm going to zoom in on my calculator here. If you had the probability of like 14 out of 17, syntax error. What did I do? Versus 15 out of 18, could you immediately tell which one was the bigger decimal or which one has the higher probability? Not unless you looked at the decimals here. And looking at those particular decimals, clearly 15 out of 18 has a higher chance of happening than 14 out of 17. So again, looking at the decimals is a much better practice than is looking at the fractions. Much better practice, in my humble opinion. It's definitely not humble. But anyway, so I could even go as far, I'm going to move this up a little bit and say like, okay, what's the probability of rolling a prime number? The probability of rolling a prime number. I could even say for this. And just for the sake of argument, a prime number is a number that only has 2 divisors. 2 divisors and nothing else. It can only be divided by 2 numbers, itself and 1. 1 technically does not count as a prime number, just for the sake of argument. 2, no, 3, and 5 are the only prime numbers on this die. 2, 3, and 5. So that's 3 possible successes, 3 possible outcomes that we're looking for out of 6 total. 3 out of 6. Yay, we did it. Which would be exactly equal to 0.5 or 0.50 if you wanted to do that, or 50%. In fact, for the sake of argument, you could even do up here 16.7%. And right here, you could do 50% if you wanted to convert them to a percentage. Again, I want you to be able to do both. But now I'm looking at this die. I'm looking at this particular die right here. And I ask the following question. What is the probability of rolling a 7? And you may ask if that's a silly question. Yes, it may be a silly question. But mathematically, you can still answer that question. And you can look over this die and you can recognize the fact that there are no 7s. There are 0 possibilities of rolling a 7. 0 possibilities out of 6 possible outcomes, which equals 0 as the decimal, and which equals 0% as the percentage. Yeah, it's impossible. But it's still a question that you can answer using probability, and that you can, what's the word I'm looking for? A problem that you can categorize using all of this probability that we just talked about today. Again, this is some very basic kind of intro stuff, but some of the stuff I need you to be able to recognize. Now, on that quizzes, I believe there were some questions in regards to cards and playing cards or something like that. Poker is an interesting game. Again, being the statistician that I am, I will admit this, I do know a lot. You like how easy that question was. I do know a lot about playing cards. I do. Now, do I gamble? No, I don't gamble. Mr. Markey, if you know so much about this and your dad took you to all these like racetracks when you were a kid, why don't you gamble? Because gambling is stupid. Gambling is stupid. Because it doesn't matter when you are gambling at a casino, the house always wins. You might walk away with $100 one night, but you'll leave another night losing $2,000. Gambling, I've seen the addictions that gambling can have. Or I've seen the type of addictions that it can develop into. And I am not promoting that whatsoever. But I do understand the mathematics behind poker, and I do enjoy it. If we were playing, with fake money, I would totally wreck any one of you just for fun. But anyway, I digress. Let's talk about some basics of playing cards. And then I want to go into some probability questions using cards. So, first of all, in a standard deck of cards. Now, I have to go over this simply because a lot of people don't know what a standard deck of cards is made up of. So I just need to review that with you so that you recognize like, oh, that's what he's referring to. So just for the sake of argument. In a standard deck of cards, there are clearly 52 cards. There are 2 jokers, but we don't count the jokers. Technically, the reason why the jokers are there are to replace any cards that get damaged or lost, but we are not counting the jokers. The jokers are not supposed to be in the deck, but I digress. Again, there are 4 suits. Those suits are hearts, diamonds, if I could spell diamonds today, diamonds, clubs. I ran out of space, but spades. People are like, clovers. No, it's not a clover. It's a club. Again, just to recognize these things. There are 4 suits, and you can obviously, if you've ever seen a deck of cards, you recognize what those things are. I have a deck of cards around here somewhere. They're probably near my marbles, but again, I haven't been in my room for a week and a half, so I don't know where anything is. Now, there are 13 cards per suit. There are 13 cards per suit, meaning there are 13 hearts, there are 13 diamonds, there are 13 clubs, there are 13 spades. Now, I may also refer to those. They may also, I'm going to put AKA, also known as kinds. They're also known as kinds. And what I mean by that, I mean like three of a kind, or four of a kind, or two of a kind, or something like that. You know, there are 13 cards per suit, or there are 13 kinds per suit, meaning I can have, you know, a king is a kind of card, a queen is a kind of card, things like that. So just so we are all on the same page. Furthermore, there are 12 what we call face cards. There are 12 face cards. Now, to be very clear, a face card is a card with a face. I didn't think that I would have to describe that. But people tend to kind of mess this up a little bit. There are 12 face cards because the only kinds of face cards that count are kings, queens, and jacks. Aces do not count as face cards, just for the sake of argument. Yeah. Now, eventually, not today, but eventually, I'm going to explain to you the different kinds of 5-card hands that you can have in a game of poker. And the idea of like, well, if we're playing poker and I have a straight, meaning I have like 5 cards all in a row of like, you know, like I have 5, 6, 7, 8, 9 or something like that. Or I have a 10, jack, queen, king, ace. If I have a straight and you have a flush, who wins? That's an amazing question. Now, I'm not going to give that away just yet. Obviously, you could Google it right now if you wanted to. But who wins is the type of hand that shows up less often. The type of hand that has a lower probability of happening. And again, I'm going to teach you how to do all those things in another lesson. This is an intro to probability. So these are all the basics of cards that you need to recognize for now. You need to recognize there are 4 suits. There are 13 cards per suit, also known as kinds. And there are 12 face cards. Now, face cards are obviously kinds, but I just wanted to give you that heads up right there. Haha. So anyway, let me flip that over. And now let me ask like a very kind of basic question right here. Obviously, what is the probability that you have a deck of cards and that you pull out, I don't know, let's say you pull out a king, for example. The probability of just getting a king. Very basic question. Well, how many possibilities of winning are winning this hand are you? Or not winning this hand really, but like of winning this probability. Favorable outcomes, well, there are 4 kings out of 52 possibilities. Very basic kind of thing right there. And that would give you approximately 0.077 if you were to round it. 0.077. So you have about a 7.7% chance of randomly pulling a card and it being a king. What is the probability of pulling out a heart? Well, again, you know, as long as it's a randomized deck, there are 52 possibilities in that deck. There are 13 hearts, 13 out of 52. Now, at this point, you might be like, well, hearts make up one of the 4 suits. One of the 4 suits. One of the 4. There's a point that I'm getting to. Hopefully you can see my calculator right here, but if I did 13 divided by 52, clearly it gives you exactly 0.25. And that should make sense. 25% chance. You have a 25% chance of pulling out a heart. But now I change up the question. And I say something along the lines of, okay, what's the probability of pulling out a king or a 10? A king or a 10. Now I've changed up the question. I'm not asking just for one type of card now, or one kind of card now. I'm asking for two different kinds. I'm asking for the probability of a king, which there are 4 kings. I'm asking for the probability of a 10, which there are 4 10s. To answer the question, one or the other, it's an 8 out of 52 chance. Let me move that down because I see the glare there already. I see the glare there. Don't worry. There you go. A little bit more. Okay. 8 out of 52, if you were to do that calculation, would give you approximately 0.154, which makes sense. Makes perfect sense since that's double 0.077. It's exactly double. It just works. It does exactly what it's supposed to do. But now I throw a curveball at you. Now I ask for the probability of a king or a heart. Now I ask for the probability of a king or a heart. Now, this probability has a little bit of an issue behind it, and some of you may recognize what that issue is. There are 4 kings. There are 13 hearts. But there is one card that is both. And that is an issue. The fact that there is one card that fits into both categories, king and hearts, we have to take that into account. Now, I'm going to put this on the board, and then I'm going to quickly erase it just as much, just because it's, I don't want to actually leave it on the board, So, but if you're talking about kings, there's, as we said, there are 4 kings. Actually, yeah. There's the king of hearts, there's the king of diamonds, there's the king of spades, there's the king of clubs. There are the 4 kings there. Now, in terms of hearts, there's the 2 of hearts, there's the 3 of hearts, there's the 4 of hearts, there's the 5 of hearts. I'm doing this for a reason. 6 of hearts, 7 of hearts, 8 of hearts. Yeah, that's a 9. 9 of hearts, 10 of hearts, jack of hearts, queen of hearts, king of hearts, and ace of hearts. Is that the answer or the exception? What do you mean, the answer or the exception? I'm going to let you type that into the chat while I kind of explain this. Yes, there are 4 kings. Yes, there are 13 hearts. But there is one card that you are counting twice in this particular instance. There's one card that you are counting twice. And you can't count that card twice. You can't. Now, this happens from time to time, where if they give you a problem of 2 events, event A or event B, you are going to have to do some kind of course correction here. Now, it also makes sense to visualize it like this. Oh, okay, she said never mind. It also helps to visualize it like this. Here are the kings. Here are the hearts. There's a, like I literally just wrote this out before, but like there's the king of spades, the king of hearts, the king of diamonds, and the king of clubs. However, the king of hearts is what is in the overlap between the two. Thought it was the answer or something. Oh, okay. Yeah, it's a Venn diagram. Now, I'm not going to rewrite all the hearts, but you can clearly see that there is one card that you are counting in both categories, and that is not something that we can deal with right now. We have to account for that. We have to get rid of it. Now, there are a lot of different versions of getting rid of it that a lot of people have, but I'll give you the most basic, straightforward, easiest way to understand it. I'm going to give you a formula. Now, in this case, I am going to do 4 out of 52 plus 8 out of 52. I'm sorry, 8. What am I talking about? 13. There we go. But then I am going to have to subtract the 1 out of 52 that we talked about. The 1 out of 52 is the one card that both events had in common. That would be the proper way of doing this problem. And I'm going to give you that formula in a moment. Now that 4, 4 plus 13 minus 1 gives you 16 out of 52, which is approximately 0.308 when you round that up. 0.308 when you round that up. I'll zoom back out a little. There we go. Here's the formula. Here's the formula. The formula that you need is this. The probability of A or B. The probability of A or B. Event A, event B. I don't know what these events are in the generic sense, but I want to make sure that you have that there. Is equal to the probability of A, whatever that A is, in this case kings for our example, plus the probability of B, which in this case was hearts, minus the probability of A and B, which would be the probability of both. The probability of A and B is the probability of both of those events happening at the same time. Now, the thing that I would like to point out as I walk up to the board right here, we had an OR problem up here before. We had king or 10. How come we didn't have to subtract anything? According to this formula, you're supposed to subtract the probability of both events happening at the same time. Ask yourself the question, is there a chance of a king and a 10 being drawn on one card? If you randomly pull one card from a deck, it's not possible. There you go. It's not possible to get a king and a 10. So technically, using the formula at the bottom, you would subtract 0 out of 52. Yeah. So it'd be like 4 out of 52 plus 4 out of 52 minus 0 out of 52, which of course would just give you 8 out of 52. Ah, there's my bell. But this is exactly where I wanted to end anyway. So make sure you have that formula written down, because we're going to be working with that and some more formulas next time. But in the meantime, ladies and gentlemen, I'm done. You can pack up your things. You can meander down the hallway to your next class. Goodbye, everyone in the room. Goodbye, 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 goodbye. I'll see you on Wednesday. Don't forget that thing under your desk. I don't know. I need to take a nap. Anyway, this has been fun. We'll see you guys next time. I'm going to sign off on the stream. Goodbye.